I'm Louis from Strategic Metals. Today, we want to share briefly some new breakthrough technologies coming our way because of two technology metals, gallium and indium. So, this further evidences our theme of how you can profit from progress and that we are still in or at the dawn of the age of technology metals. I think it would be safe to say actually we're in a technological kindergarten compared to what's coming. So let's begin with robotics and the question: what country is leading the way in industrial operational robots worldwide? So in 2022, a new record number of 3.9 million operational industrial robots was reached worldwide. Now, this is according to the International Federation of Robotics, IFR, their figures. So, in terms of robot density, the countries with the highest levels of automation are South Korea, with 1,012 robots installed per 10,000 employees. Singapore is next with 730 robots, and Germany with 415. So, contrary to the slowdown in global economic growth, the IFR expects this trend to continue. So, this could and should also lead to a further increase in demand for certain raw materials, i.e., um, gallium and indium. A study commissioned by the European Commission in 2020 named critical minerals such as gallium and indium. Gallium and indium made the news again regarding wearable medical devices and vision restoration. So scientists have successfully tested what they call ultra thin retinal prosthesis using gallium and indium for the first time. South Korean researchers from Yonsei University in Seoul have developed an artificial retina that will revolutionize vision restoration. So, in a paper published in the science journal Nature Nanotechnology, the team under Wang Ji Chung from the Department of Material Sciences and Engineering at Yonsei explains the benefit of the new retina. So, for example, what we use currently, electronic retinal prosthesis or bionic eyes, also known as bionic eyes, are sort of inflexible, and their rigid electrodes can inflict damage to soft tissue around the retina. Now, with the new artificial retina, it's made of softer material, and inflexible electrodes are replaced by integrating phototransistors with three-dimensional liquid metal microelectrodes, known as eutectic. So, eutectic gallium indium alloy. Eutectic means that the alloy has a lower melting point than its constituents. And the researchers sort of also explained that the combination of softer material and the liquid nature of the microelectrodes prevents possible damage to the surrounding tissue. In addition, the electrodes are locally coated with platinum, which helps in injecting charges into the retinal neurons, therefore enhancing the electrodes transmission sort of properties to the retinal neurons. Now, because of what you might say, the liquid state of the gallium indium alloy, the artificial retina is then rinsed and frozen to solidify before implementation, or implantation, I should say. So basically, the low melting point of gallium is one of the metal's core benefits to comparable elements, and is one of the reasons the metal has grabbed the attention of researchers trying to enhance technologies. Another example, injections and blood sampling could be facilitated using needles that soften when injected. Gallium's low melting point is not its only asset. Another American startup actually utilizes gallium nitride semiconductors super efficiency in transmitting currents compared to silicon based versions to defrost airplane wings. So this could help prevent delays at airports in the future. Now, just going back to robotics very quickly before we leave you, what about a shape shifting robot? Possible? We saw it in CGI in the Terminator movies, and now, thanks to gallium and indium, it has become a reality. So if you Google, I think it's scientists, if you Google scientists liquefy shape shifting robot in cage, if you Google that, you'll see the video itself. It's fascinating to see. So because of again, the low melting point and gallium and indium as an alloy with electrodes placed, what you'll see is a little small robot in a prison cell in metal form, and it liquefies, slips out of the prison, if you will, and metallizes, becomes metal again. It's again, we saw this in CGI, but it's now become a reality. Now, probably, I don't know, maybe it will have military uses, but actually, what the scientists are saying is mostly where it'll be beneficial will be in sometime in the future. Those they can be miniature robots injected into the bloodstream that can go and retrieve or capture bacteria and remove it, and eventually, even maybe be used in cancer treatment. So, again, you've heard us say many times, by owning these physical assets, gallium, indium, terbium, technology metals, rare earth elements, you can profit from progress. And we really are just at the beginning. We're in the kindergarten of the dawning of the age of technology metals and what's coming. I mean, the same metals, that we're talking about today in these applications are also needed in modern technology. You wouldn't swipe your screen without indium, aerospace, you name it. There's practically not an industry where there's no application for these, what we call strategic metals. So look, thank you very much. If you have any comments or views or ideas to share, we always welcome your comments in the comment section. If you would like to learn more about owning gallium or indium as a physical asset, you could reach out to me, Louis, at strategicmetalsinvest.com, or you can go directly to our website to download a brochure, Strategic Metals Invest. So thank you very much.